Imagine the sun, our familiar celestial anchor, swelling. Not just a little, but to a monstrous size, engulfing Mercury, Venus, and perhaps even Earth. Its outer layers, once a beacon of life-giving light, would transform into a vast, ethereal shroud, glowing with the ghost of its former glory. This isn't science fiction. It's the predictable, albeit dramatic, fate of stars like our own. But what happens when the truly massive stars, those titans, many times the mass of our Sun, reach the end of their multi-billion-year journeys? Their finales are not gentle dissipations, but cataclysmic explosions that rewrite the cosmic landscape, forging the very elements that make up you, me, and everything we know. These aren't just distant, abstract events. They are the furnaces of creation, the ultimate recyclers of the universe, and understanding them is key to understanding our own origins. What cosmic alchemy occurs when a star's life support finally fails, and what spectacular, mind-bending objects are born from such utter destruction. The story of a star's end is inextricably linked to its birth and its mass. Throughout its life, a star is locked in a titanic struggle. Gravity, relentlessly pulling inward, versus the outward pressure generated by nuclear fusion in its core. Hydrogen fuses into helium, then helium into carbon, and so on, forging heavier elements in a process called nucleosynthesis. For stars up to about 8 times the mass of our Sun, this process stops at carbon and oxygen. As fusion ceases, gravity wins. The star's core collapses catastrophically, but the outer layers rebound off the dense core in a stupendous explosion known as a Type II supernova. This blast is so powerful, it can briefly outshine an entire galaxy, scattering newly synthesized elements across interstellar space. The remaining core, if less than about 1.4 times the mass of the Sun, collapses into an incredibly dense object called a white dwarf, about the size of Earth, but containing the mass of a star.